Okay, this is the second lecture for Chapter 2, and it shouldn't take quite as long as the first one did, so we'll try to speed this up a little bit. As far as some of the naming in the Oxyanion nomenclature, there's a couple of these that we'll see here, and basically the one that's more common gets the ending 8, and the ones that have less oxygens than that usually will go with ite. So we'll see those as a couple examples moving forward. And you can kind of see these guys up here as far as group 2, or period 2, excuse me. Those typically are going to have 3 oxygens, and as you fall a little further down, they can have up to 4 oxygens. And the charges also change moving across. This is a 1, this one's a 2, and this one's a 3, minus 3 within that grouping there. Right. Now, as far as the names, this is kind of what I wanted to get to here. The one that's most commonly referred to in this example, and it's something you just kind of have to memorize, is the nice example chlorate. Chlorate is O3. It's the most common of the bunch. And then when you start pulling oxygens away, the ending goes from ate to ite. And then as you take another one away, the ending stays ite, but then you add the prefix hypo. And the most common one of that, if you know, is hypochlorite, which would be sodium hypochlorite, which is bleach. Household bleach. Now going the opposite direction, we have the most common is chlorate. If you add another oxygen going from O3 to O4, it's going to become perchlorate. And again, it's something you're going to have to memorize. We already went through that. As far as some of the other endings in there for acids, typically you're going to be looking at the halogens. They're going to have their ending, which was an ide, chloride, bromide, iodide. Those are going to change to ic. So hydrochloric, hydrobromic, those will be easy for you to memorize. You see them quite often. Some other ones, these endings go together. If it ended in ite, then you're going to change the ending to us as far as the acid goes. So nitrites would become nitrous acid. Hypochlorites would be hypochlorous acid. And the ending for this one here, if it ends in ate, nitrate would be nitric acid. And there's a couple ways we can talk about that, but we'll do that in class. Some of the beginnings, this is typically when you're talking about nonmetals. So a nice example of that is carbon dioxide. This ending can go on, prefix can go on either the first or the second element listed. So you could have dinitrogen pentoxide, but that's typically, again, we're talking about nonmetals for those. And easy enough. For the organics, and we're not going to see much at all. It's not covered very much on the AP exam. But if the carbons are all fully saturated, in which, in other words, carbon can hold 4 atoms. So if the carbon's holding all the atoms it possibly can, it ends in ane. If it has only 3 attachments, typically it's going to be, it's going to have a double bond in there, and it's going to end in ene. And if it has a triple bond in there somewhere, then again, it's not going to be hydrogen. But if it has a triple bond in there, it's going to be ine. Just some examples. And these are just some functional groups which are added. In this case, it's an alcohol, so it ends in OL. But we'll talk a little more about that in class. And that's it. That's the end of lecture number 2.